2 years from now, NASA wants to launch the first nuclear-powered freight train to Mars. Not a science fiction concept, not a distant dream. A real spacecraft, powered by a nuclear reactor, designed to slowly pull massive cargo across the solar system. And if it works, it could completely change humanity's future in space forever. Right now, traveling to Mars is painfully difficult. Every mission depends on a tiny launch window that only opens once every 2 years, when Earth and Mars align closely enough for the journey to be possible. Even then, reaching the red planet requires enormous amounts of rocket fuel. Modern rockets are powerful, but they are horribly inefficient. To send a relatively small rover to Mars, we burn through colossal amounts of fuel just escaping Earth's gravity. And when we start talking about human missions, the problem becomes terrifyingly large. SpaceX plans to use Starship to transport humans and cargo to Mars. But just getting Starship ready for the trip requires multiple launches simply to refill its fuel tanks in orbit. That means giant boosters launching over and over again, just to prepare a single spacecraft for one journey. And even after all that effort, the spacecraft still spends months drifting silently through deep space. Clearly, this cannot become the long-term future of interplanetary travel. So NASA is attempting something radically different. A nuclear spacecraft. A machine that could eventually move cargo across the solar system the same way freight trains move across continents on Earth. And the project is already happening. NASA's new spacecraft is called Space Reactor One, or SR-1. Unlike traditional rockets that rely entirely on combustion, SR-1 will use nuclear fission to generate electricity in space. The same process used inside nuclear power plants on Earth. Atoms split apart, releasing enormous amounts of energy. But instead of using that energy to create explosions like a normal rocket, NASA plans to use it to power ion thrusters. And that changes everything. If you enjoy videos about space exploration, futuristic technology, Mars missions, and the terrifying engineering shaping humanity's future beyond Earth, make sure to like this video and subscribe right now. There's a lot more coming. Traditional rockets work through violent combustion. Fuel explodes inside the engine, creating high-pressure exhaust gas that blasts out of a nozzle. That force pushes the rocket forward. It's powerful, but it's also incredibly wasteful. Rocket engines consume massive amounts of fuel because they must carry both fuel and oxygen into space. Ion propulsion works differently. Instead of explosions, ion engines use electricity to energize atoms inside a gas. Those energized particles are then accelerated and fired out of the spacecraft using electromagnetic forces. The thrust is tiny compared to a rocket engine, almost gentle, but in space, there's no atmosphere to slow you down. That means even a small amount of continuous thrust can slowly accelerate a spacecraft to enormous speeds over time. And the efficiency is extraordinary. Some nuclear electric systems could become nearly 10 times more efficient than conventional rockets. That means less fuel, more cargo, and eventually much larger missions. NASA describes this idea as building a railroad to Mars. Not a literal railroad, but a permanent transportation system moving supplies, equipment, and eventually infrastructure across deep space. And unlike giant chemical rockets that burn intensely for a few minutes, SR-1 could operate continuously for years. At the front of the spacecraft sits the nuclear reactor itself, smaller than the reactors used in submarines, but still capable of generating enough electricity to power the entire propulsion system. Heat from nuclear fission flows through special thermal pipes. That heat transforms liquid into gas. The gas expands, spins turbines, generates electricity, cools back into liquid, and repeats the process again and again in a closed loop, potentially for years without maintenance. Further down the spacecraft sits a massive radiator system designed to release excess heat into space. Because in the vacuum of space, heat becomes a deadly enemy. And at the rear of the vehicle are the ion thrusters themselves, quietly pushing, constantly accelerating, slowly pulling humanity deeper into the solar system. But perhaps the most fascinating part of this mission isn't the spacecraft itself. It's what SR-1 plans to deliver to Mars. When the spacecraft finally arrives at the red planet, it will deploy a landing capsule into the Martian atmosphere. Inside that capsule are 3 autonomous helicopter drones, successors to NASA's Ingenuity helicopter, machines designed to fly across the Martian surface searching for something humanity desperately needs: a safe place to land humans. The drones will scan the terrain for flat landing zones. They'll use ground-penetrating radar to search beneath the surface for water ice. Because future astronauts won't just need water to survive. They'll need it to create fuel for the journey back to Earth. This is no longer just robotic exploration. This is preparation for colonization. Preparation for permanent human presence on another planet. And SR-1 may become the first true cargo ship of that future. A nuclear-powered bridge between worlds. But Mars is only the beginning. NASA already plans to use similar reactor technology for future lunar bases. Nuclear systems capable of surviving the brutal 14-day lunar night when solar panels become useless and temperatures collapse into deadly darkness. And beyond that, larger reactors, more powerful spacecraft, interplanetary transport systems operating continuously between planets. The beginning of an entirely new era of human civilization. For thousands of years, humanity was trapped on Earth. Then ships crossed the oceans. Then trains connected continents. Then airplanes connected the world. And now, for the first time in history, we may be building the first true transportation network between planets. Not with roads, not with rails, but with nuclear reactors drifting silently through the darkness of space. And if you want to see the terrifying engine technology that could power humanity's future missions even further into the solar system, make sure to watch our video, The Insane Engineering Behind SpaceX's Raptor Engine. Trust me, that video is incredible.